How's it going? What's up, Eric? I'm doing pretty good. It's been a long Monday. Hello from the infamous one-man crew. Hello, Phil. Flowers of Algernon sounds really familiar, but what is that from? Got COVID traced and was sent home from the office today? Oh, that's a bummer. It's a book. Flowers of Algernon. It won the Hugo Award for Best Short Story in 1960. I'll have to check that out. What do you say we get started, guys? Quick read, but it's very thought-provoking. I think I'm gonna look into that. I've been enjoying reading recently. Reading different stuff. Well, I've been reading the Stormlight Archive. Very good. Very good. Okay, this workshop's kind of fun. It's all about pulse width modulation. And we talked about it in lecture, but it's a way, because the pins on the Arduino, they can only turn on and off, high or low. So how can you generate some voltage in between high or low? And so we do it with PWM. Let's go over here. But basically, like, this is what a PWM signal looks like. You turn on and off, and you can vary the pulse width. And so the duty cycle is saying, like, the percentage of time that the pin is on over a cycle period. So it's on 25% of the time, here 50%, so on. And so that changes the effective voltage of the pin. So let's jump right into the first exercise. We get to use an RGB LED. So you want to find your RGB LED from your kit. It's an LED with 4 different leads. Did you guys find it? And I'm using the teeny tiny breadboard for this because it's just adorable. Let's pull this up again. But you can see the longest lead is the ground, and then you have red, green, and blue. And like in this figure here, I'm using a red wire to go to the red lead, green to go to the green, blue to go to the blue. And we need some 220 ohm resistors to go in between the board and the lead of the LED, because this will resist the amount of current going through there. So let's hook it up. Let's get to it. Alright, so red is going to be up here. Fortunately, this plugs in really easy. And then I already grabbed some 220 ohm resistors out of my kit. So I got that 220 going to the red. And then I'm going to skip a row because the ground is actually the next one. So I skipped one, now I'm going to the green. And then we're going to go to blue. Red, green. Okay. And then I have some wires. So I'll do the red up top. Yeah, flowers for Algernon. I'm wondering if I read that like in high school or something. Because it just sounds so familiar to me. Like, I'm kind of remembering somebody in the rain and like a flower petal. Like, I have some image in my mind that it's not a happy story. I don't know if I'm thinking of the same thing. Okay, and then this black wire is going to go to the ground pin. Okay. All right, and now we're going to connect. So the PWM pins on here are indicated with this little tilde. So like 11, 10, 9, those are PWM pins, 6, 5, 3. I'm going to use pins 11, 10, and 9 for the red, the green, and the blue. So 11, I'm gonna make that red. Green, I'm gonna make that 10. And then 9, I'm gonna make that blue. And ground, well, we just have a handy ground pin right here. And that's the circuit for this first exercise. We got the RGB LED hooked up. We got the resistors. We have the ground. Now, in RGB LED, we probably have no hope of seeing inside there, but there's a tiny red LED, green LED, a blue LED, and basically, if you send different proportions of voltage to the red, green, or the blue, the overall color here is gonna change. So let's open up a sample code, why don't we? Because the first exercise is trying to get this to turn orange. All right, we need to open a sample code. Let me find it. And it looks like this. So remember, we hooked up the red pin to 11, the green to 10, the blue to 9, and let's skip this for a second. We'll skip the duty cycle. And then in the setup, you set each of these modes, the pins to output. Can we plug one resistor into ground? Wait, do you mean like putting a resistor? No, you don't need a resistor for ground. I guess you could, and that would just resist the amount of current flowing through there, but you certainly don't need it. I mean, instead of 3. Oh! Huh. Okay, but if you did, I guess you could. That's a nice idea, Eric. I think you could. So we set each of these modes to output. And then, this is how we send a PWM signal from a PWM pin. So let's say we want to send a PWM signal from the red pin. Basically, you have to send a number between 0 and 255. 255 means the pin is always on, like 100% duty cycle. If you send half of 255, which is what, like 122, it'll be on half the time. Wait, what if we pull this up again? Oh, like 127 would be like a halfway on, 50% duty cycle. So anyways, the way I like to specify this number between 0 and 255 is I like to just take 255 and multiply it by a fraction. So if I want 50% duty cycle, I just take 255 and I like to multiply it by 0.5. So like before the setup, you can specify like a constant duty cycle if you're going to keep it constant. And so the effective voltage here, if we do 50% duty cycle, it's alternating quickly between 0 and 5 volts, and it's on for half the time. So the effective voltage will be 2.5 volts that we're sending to the red. And basically, so 0.8, this has a higher duty cycle. The green is going to be on for a greater portion of time, so it's getting a greater voltage. And so you can play with these duty cycles to play with the proportion of voltage sent to each LED, and that mixes the color. So how about we just experiment first? Like we can set this to 0 and 0, and I'm going to upload this, and the LED should only turn red because only the red one is getting any voltage. I actually need to plug in. Okay. I gotta change my port. Upload. Is the duty cycle in seconds? No. Wait. I only turned on the red. A percentage of the max voltage? No, duty cycle is the percentage of time that the pin is on. Oh, I had an error uploading to the board. So a duty cycle of 50%. Oh, because I have a mega specified here. I have to change it to uno. A duty cycle of 50% means that pin is on 50% of the time. Okay. Now that I specified the correct board, this should upload. Okay, and now you see it's red. And I can make this brighter by increasing the duty cycle at that pin. So if I make it on 75% of the time, it's going to have a higher effective voltage and it'll be brighter. And it's a little brighter. Okay, so if we go back here, the goal of the very first exercise is to make the light orange So if we Google flowers of Algernon, I mean orange, RGB. Oh, and there's different oranges we can look at. So the refresh rate of the PWM greater than we can visualize? Yes. The refresh rate of the PWM is, depending on the pin, it's either 980 hertz or 490 hertz. Most of the PWM pins are 490 hertz. 500 times a second, it's flicking on and off. Okay, so like if we're going for orange, red, and this RGB, the way this works is the maximum value is 255, which actually coincides with duty cycle, which is pretty nice. So if we did something like 100% duty cycle for the red, 69% duty cycle for the green, and 0 for the blue, we should get something similar to orange, right? And we could try it. 1.0, 69, blue. This looks actually a little more yellow to me. And we won't be like, it looks kind of green, right? Maybe we need, so you don't have to like be, you don't have to go crazy over this, but maybe proportionately less green. That looks a little more orange. What if I keep bringing it down, like the green portion? Oh, that looks pretty orange to me. So the idea for the first exercise is just to play around with the proportions, and it gives you a basic idea of the understanding of PWM. It lets you modify the relative voltage that these pins are getting. I should have paid attention to art class after all. I know. Now it's coming back. Okay. This is really bright, by the way. That's a lot. But that's the first exercise. Let's just move right along. Let's move right along. Okay, so this next exercise is a little more challenging. You modify the sketch so that the light linearly transitions from pure red to pure green over a 5-second interval and then repeats. And there's not just one way to do this, so I make a note of that. And this one, I'm not going to give this away to you. I mean, starting at pure green, or starting at pure red, we know that we are going to have some voltage sent to red and then no voltage to red or blue. And then we want to transition to green. So gradually we have to be reducing the voltage being sent to red and increasing the voltage sent to green. And so you can modify it. You can lower the duty cycle for red and increase the duty cycle for green until it's 0 duty cycle for red and 100% duty cycle for green. And then once you've gotten to that point, it says like repeat. So start back at full red and then it'll keep switching. Let's see. I don't know if I have code ready to go to just demonstrate it. Let's see, what do I got here? Oh, maybe I do. Let's see if I can upload this. I'm not going to show you this code. Not going to show you. But you'll see the final result. Let's see what this does. Ooh. Pretty cool. So it starts at pure red, and then it becomes more yellow, and then it becomes pure green. And this is happening over a 5-second interval. Let me, maybe I can put a timer right next to this. Timer. Wait, stopwatch, I mean. Once it goes red, we're gonna 2, 3, 4, 5, and then it's back. It's kind of fun. So it's just modifying the duty cycle over time. Okay, so for the sake of time, I'm going to start talking about this next one. So this next one, you're going to use the joystick as a sensor to control the duty cycle of these PWM pins. And so you have a joystick. Looks like this. It's in your kit. And how about we just hook up the joystick first? So the joystick is just, it's a potentiometer. Like you can see, it takes in a 5-volt source. If I move this. Ground, and then it has a potentiometer for the X direction and the Y direction. So as you move this all the way around, actually we'll open up the code and see how the serial monitor changes. You'll get to see the readings come off of this. Let me disconnect this real quick. So we're going to connect this. In your kit, you should have some like female to male wires that you can use. So like it'll just have some leads coming off. So I have a black wire that I'm using for ground. Doesn't matter which color you pick. So I'm going to connect that to ground over here. And the red wire I had going to the 5-volt source. So I'm going to connect that to 5 volts. You can focus, do it. All right, and then let's see. I have the white wire going to the X direction and the orange wire going to the Y direction. I need to get better with this focusing. I can't remember from the joystick sample code if I want the X to go to 0 and the Y to 1, but we're going to put it at these analog inputs. So I'll take the X direction is white. I'm going to plug it into 0, A0. What am I missing with like autofocus? Maybe I should have a white background. Maybe that'll... Maybe it finds the grain of the desk too interesting. Seems better. Okay, and now this is the orange wire. It's the other axis of the joystick. We're going to A1. All right. So now we still have that RGB LED, and then we have the joystick as well. Oh yeah, this autofocus is so much better with... Okay. Alright, I'm going to find the joystick sample code. Okay. So you'll notice this code looks very much the same as the RGB LED code, but we added the 2 pins for the joystick, the X and the Y direction, and went to analog 0 and analog 1. And then I have an integer variable to store the ADC values from the X and Y direction. And I'm also initializing the serial monitor so we can see the data coming off of this thing. Okay, so let's just upload this code first. Plugging this in. Change this to Uno. Upload. Okay, I'm gonna pull open the serial monitor first. Oh, I have to change this baud rate to 9600. Okay, so check this out. When the joystick is just sitting at the middle, it's giving ADC readings of 509 and 499. But notice as I move this around, the X just went to 0 going all the way this way. So this must be the X direction. And then X goes to 1023 the other way. So this is X. Y is changing very little. And then this other motion side to side, look, Y went to 0, and then Y goes to 1023. And then if you move around in a circular motion, you see you're changing both values. This is actually better to see if you open the serial plotter, because it'll show the ADC values from X and Y just changing. Pretty cool, right? I mean, this is the same thing going on with your PlayStation controller. You guys can make your own gamepad now. Pretty sweet, right? So the goal is, as I move this around, I want the X direction to correspond to changing the proportion of red, I think. Let's check the goal again. So X direction corresponds to the duty cycle for red. And the Y direction corresponds to duty cycles for blue. So the goal with this workshop, I mean for this particular exercise, is as I move this around, it changes the proportion of red and blue, and you're going to see the color change as I change the joystick. So once again, I won't give away this code, but I'm going to show you the result that I get. Let's see if I can find this. This one's really fun. Okay, red, blue. You actually don't have to change the original code that much to get this to work. I think in the sample code I indicate the 2 lines that you need to make a modification on. So it's not... Ooh, it's uploading. Oh, it gave me an error because I still had my serial monitor open. Okay. So right now, the joystick is in the middle, so it should be pretty much equal parts red and blue. And actually you can see the reflection on the joystick. It's kind of purple. Now if I move it over to this side, it's adding more red, more blue. If I go this way, not so clear. Okay, this side, wait, this is pure blue right here for sure. Oh wait, I have it editing blue and green right now. I don't have it editing blue and red. What does the workshop ask for? Blue and red. Oh, I had it doing blue and green, I think. Wait, I think I can make a quick change. Red should be the... X direction should be red, Y should be blue. Okay, let's change it. Red, blue. Alright, that's blue. Oh, okay, that's working now. Move the joystick this way, it's pure blue. Now it's like purple. Over here it's pure red. Blue, pure red, and then Raw Yolks. Hey, when you're done, you're welcome to raid Enceladiosaurus and learn some math in a super accessible way. Sick. Thank you. Oh, and then if you move up to like this corner, it's 0 red and 0 blue at the same time, so it just turns it off. And then I think if you move to the opposite corner, it's full red and full blue at the same time, so it's just maxing it out. Off, full, red, blue. So kind of fun. Okay. That's the third part, the third exercise. Let's talk about the fourth, which is hooking up the DC motor. So let's just build the circuit together. There's a couple things I want to point out. So I'm just going to unplug everything here. Just unplug everything from our Uno. And I'm going to get out our bigger breadboard. And the first thing I want to hook up is this power block. And this is where we're going to plug in our external power supply. So take your breadboard, and this actually plugs in very nicely. Doesn't matter exactly like in terms of along the breadboard you put it, but I kind of like to secure it somewhere up here. All right. And then you need to find your L293D motor driver. And it's a little deceptive because there's two different chips in your kit that look very similar to this. So you have to make sure you find the right one. Actually, and the way that I can tell is there's a little like circle. I'm always having trouble focusing here, but come on, buddy. In the bottom left, there's a little circle. Ah, there you go. You can see it. I think the other chip that you might confuse this with doesn't have that circle. I'm just snooping around. Here we go. I'm gonna dig the other chip out of here. This is the one you don't want. This one. It's very easy to mistake them. They have the same number of pins. This is the one you want. Not this one. So see that circle? Okay. So we're going to take this and we're going to put it this way with like the circle facing towards your power board. And you're going to bridge the gap, kind of secure it in there. Boom. Wonderful. Both of mine have circles? Wait, are you like it has a half circle on both of them? Does yours, like this one has that half circle, but it doesn't have like the other circle. Does yours have a circle? The other thing you can do is this might not focus, but it actually prints L293D on the top of this thing. Maybe I can get more light on this. That's another way to check though. Okay, yeah, if you can, I know I won't be able to zoom in enough with what I have, but you can kind of see there's text on the top and you'll see L293D like printed there. Okay. Let's start plugging some stuff in. All right, so first of all, when we plug in the 9-volt battery to this, we're not going to do it yet. That's going to charge this rail next to the red line with 5 volts. And we're going to plug that 5 volts into the very last pin on this side. So you see this row is connected with that pin. So we're going to have 5 volts going in there. And then this blue is going to be ground. And ground is going to go to this 4th pin from the top. That's a little tricky because I know this thing's little. But you can see I got this into the 4th row. 1, 2, 3, 4. And I'm just going to stick that in the ground rail. So we have 5 volts and ground that are going to go there. Let's get the Arduino involved here, because the Arduino is going to share a common ground. So let's take another pin in the ground and connect it to the ground of the Arduino. Ground. All right, now let's connect the PWM pins to our motor driver. So I'm going to connect pin 5. Oops, I plugged it into pin 6 instead. You can always check the side to make sure you're in the right one. And this, pin 5, is going to go to the very top pin of the motor driver. This little one up here. And this is going to control the motor's speed. We're going to send a duty cycle out of this. Full duty cycle is going to be full speed of the motor, and so on. All right, now we're going to connect 2 more PWM pins. We're going to use pin 4, so right next to pin 5. And this one's going to go right next to the other guy in the second pin for the motor driver. All right, so those are going to go right next to each other. This orange pin is going to be responsible for controlling the direction of rotation. And we actually need another pin working with it. So we're going to go to pin 3, which actually isn't a PWM pin. Or wait, it is, I think. Yeah, it is. But we're actually not using PWM with these 2 pins, pins 4 and 3. These are going to be used to specify direction, not so much duty cycle. Okay, so I need to connect this right next to the power pin. Straighten this out a little. Come on, buddy. Okay. And so this is connecting right next to the power. It's on the second pin from the bottom of the motor driver. So now we have 5 pins going into the motor driver. The 2 top, the 2 bottom, and then the ground is to the 4th from the top. Okay, now's where we actually connect the motor. And if you're very lucky, your motor from the kit still has both of its leads intact. How many of you still have your leads like still connected to the DC motor? And how many of you have it broken? Yours broke? Yeah, both of my leads broke. Ooh, flowers. Very fortunate. If you still have yours intact, good for you. That's amazing. So what we're gonna do, because mine are not intact, I'm gonna take a long jumper wire. I'm just picking red, and I'm gonna plug it into the 3rd row from the top. Oops. On the driver. So we have the top 2 that are going to the PWM, and then this 3rd from the top. This is going to go to one of the leads of the motor, and it doesn't matter which, okay? I could switch it if I wanted. That'll just switch the direction of rotation. All right. Then I'm going to take another jumper wire. This one just black. And I'm going to take the 3rd row from the bottom, plug that in. This is going to go to the other lead of the DC motor. All right? And so if I connect these, it'll power up the DC motor. All right, so we haven't connected the 9-volt power source yet. What I want to do is upload the DC motor sample code to the Arduino first. So I'm going to plug in my USB, and let's find that sample code. Excuse me. Okay. So pin 5 on the Arduino, that's the PWM pin. This regulates the speed of the motor. The other pins 3 and 4, those are going to change the direction. And this duty cycle, that's the duty cycle that we'll send to the PWM pin. So we specify all of those pins as outputs. And then here's what we're doing in the loop. First, with pins 3 and 4, we specify a direction. Like if you have one of them high and the other low, that corresponds to one direction of rotation. If you want to change the direction of rotation, you switch this to low and change it to high. And that's what we do later on in the code, actually. We switch the direction. Okay, so once you specify the direction, then you specify the voltage that you send to the motor. And you do that by changing the duty cycle. So right now, this is at 70% duty cycle. And it's going to send that and generate some speed. So we're going to spin one direction. We're going to do it for 1 second because we're going to wait 1,000 milliseconds here. And then we're going to change the direction and spin the other way. And then wait again. So let's upload this code. To make sure this is an Uno. Port Uno. I should be able to upload this. Okay. So it uploaded. I'm going to come back over here. And so next what I'm going to do, where's my battery? We got to find the 9-volt battery to plug in here. Okay, so you should have a battery in your kit, and there's this this DC jack you can connect to the top. So let's plug in that 9-volt source. And now you can see a green light pop on. And actually, if you're ever not getting power, there's a little button on the top here. And I don't know if it has to be up or down, but this is something you can check. I think you have to have this down to engage the power source. So now we're getting 5 volts of power along that rail. And the routine is running on here. So what I'm going to do, I'm just going to rest my motor right here. And I'm going to connect one lead and then the other, and this should start spinning. Just trying to get a secure position here. So it's spinning one way and then it's going the other. I know it might be a little hard for you to see. What I can do, I'm going to try to take this to the edge of the table and connect this fan, because this makes it obviously easier to visualize. Okay, you can see it. Cool. We'll just do this for giggles. Maybe that won't work. I don't know. I'll try to like position it with my hand. Yeah, it's easier to see. Goes one way, then the other. Okay, so if that's working for you, you've gotten it. Now the workshop exercise, let's see what it says. The first one, it's just modify the sketch so that the motor spins with 70% duty cycle in one direction for 3 seconds. Then it goes in the other direction with 90% duty cycle for 2 seconds. So you can just modify that code. This one's pretty straightforward. So this should be no problem. Now the next one is a bonus, meaning it's not mandatory to do, but I think it's really fun. I made it a bonus just in the interest of time. for people who are doing the in-person workshop. If they're running short on time assembling everything, I don't want them to feel rushed. But if you have the time and want to do this, we're going to hook up the joystick, and we hook it up in the same way we did before with the RGB LED. And then we want to modify this code for the motor so that pushing the joystick in one direction spins up the motor in that direction, and the amount that you pushed in one direction should increase the speed. So you'll be able to proportionally control the motor speed and the direction with the joystick, which is really fun. I don't have an example code to show you exactly what that looks like here, but I think you could imagine it. And that's it. That's the rundown of Workshop 4 and what you're doing this week. It's fun to play with. It's satisfying when you get each of these working, so I hope you guys do enjoy. And that's all I have for you tonight. I hope you guys are doing well. Hope your week is off to a good start. Trying to finish the report. Yep. I hear you. All right, everybody. With that, a mad dash to the finish. I hear you. With that, we will conclude our session for tonight. Have a great rest of your week. Good luck with your lab reports and all your other classes. Hang in there, guys. All right, I'm going to sign out. Peace.